Hello and welcome to another video on Unreal Engine 5. In this video we will make the MLRS shoot at the player or any actor we select. Previously on the previous videos we made the MLRS shoot according to the range we set, and we set a camera to see where it shoots, and in this video we'll make it shoot on its own when it sees the player, or uh, the other, or we can set it to shoot at any other object in the map. Now let's start. First let's go to the MLRS blueprint. What we need, I will not make it move and follow zipline or follow player because I made it before in the previous video. I will put a link to it. It will appear on the eye icon on the left upper side of the video. Now what we need is the location of the actor that we need to shoot at. We can set an actor, make a new variable, call it actor, and the set it to actor object reference. Make it instance editable and exposed on spawn. Now let's make new custom event, call it shoot at actor. Here we need to repeat some of the previous logic of the predicting the arc of the projectile. We need the start point. First we need the start point. Let's copy it or duplicate. Also we need the now also we need the endpoint and the suggest velocity. Get start point and endpoint. The endpoint will be the actor location that we set in the in the level. Get actor location. And we need to set the launcher angle to make it look like it is predicting the angle of the launcher to shoot at the player and the actor. To make this we need to specify a range that the MLRS can shoot the player at. Let's make a new variable, call it range. This range variable will limit the range of the vehicle that can shoot at, and also will serve as a check and for the angle of the launcher. Get the range. Let's set it 100,000 equals to 1000 meters in real life. Now first we need to check if the actor is within the range. Get actor location. and we need the location of the our actor, the MLRS. Let me make some space. Now we need to subtract the location of the actor from our actor location, the actor we want to shoot at from our actor location. This will give us the distance between these between our MLRS and the actor we want to shoot at. Let's get the length. It gives a vector. We need the length of the vector length. Now we need to check if the vector of the range or the vector length is below or equal to the range. If it is below or equal, we can shoot. The MLRS can shoot at the actor. Now we need the angle. Let's get the range. Previously we multiplied the angle by 2500. Now we will reverse it. We will divide the range by 2000 to make it look realistic. And clamps a float between 1 and 45. Now set it to be the launcher pitch that we made previously. And to get the yaw, look at rotation. The start is our location. The target is the actor that we want to shoot at. Now we need the delta rotation. Delta rotator. Get actor rotation. Now we do break the rotator and set 0 to the launcher yaw. And I want to limit it to between minus 90 and 90, because at the extreme of the angles between 180 and minus 180, when it tries to go to the between minus 180 and 180, it will turn the other way. Let me show you how. Here we did not limit the rotation. See, if we rotate it too far, it will return and then go back to the other way, and this is not realistic, and also sometimes cause problems with the shooting. I will change the limit to minus 170 to 170. Now what we need, or let's decrease it, minus 135. and to 135. And we will make the MLRS change position of the player or the actor outside these values. Now let's comment on this. Look at player. And set the projectile velocity. Now we need to make it shoot. We already did the shooting, just we need to make a custom event called shoot. Let's make another boolean. Oh, this old boolean here. Let me delete it and make a new one. Call it AI controlled. This will help us switch between control if the vehicle is controlled by AI or controlled by us. Make a branch. Or not boolean. It is not controlled by AI. We can shoot when we can control it by player. Let's make it also an instance editable, and we do not need text on this one. Let's also put this on the controls. Sometimes you do not need this, but for extra security, sometimes you get errors. Camera also, because this also sets the yaw and pitch of the launcher. Now here in the shooting, let me see, let's put a delay here before the spawning of the rocket. This will serve as the rate of fire. Let's make it every 2 seconds it shoots one projectile. Now here let's implement the shoot event. Now let's get the branch, not boolean, and here also look at player. Look at what did we call the custom event? Shoot at actor. Shoot at actor. Now let's test. And also, I forgot, if it is not controlled by a player, we need to set the scene component to be inactive, because this also affects performance. If it is active and we do not use it, deactivate. Because it acts as a second camera. Now let's disable this. AI controlled. Now I will spawn in my BTR. Let me just rotate it here. Now let's see. Oh, sorry, I didn't make it choose my player. No, it's not shooting at me. Sorry, we didn't set the actor. The actor, make it BTR. Shooting at me. We change position. That was me. Shoot at me. Is limited to this position. Now, first let's make the yaw and pitch be smooth, move smoothly instead of snapping to the position. Let's use the F interp. This will permit smooth transition of the float value. Now here in the current we put the pitch, and the target we put our float value. Delta time we get it from the world delta seconds. World delta seconds, and interp speed 1. If you want it to be slower, put it below 1, but not 0. If 0, it will snap to target. The same, we'll copy this and use it here in the U. But remember to change the pitch, this to U. Also, let's add another check in the shooting. I want it, if it is outside the angles that we set, I want it to not shoot and change position. here we set it before if it is between -25, and also the pitch, let's make it make a branch. Now we need to clamp the axis, clamp axis. This will change the value of the float from uh, the 180 values, 180 or -180 to 360. It will make the angle as 360, not limited to 180 or -180, because if we do not use the clamp, to the left will be minus, the value will be minus, and to the right of the actor of our actor, let's say if we are using the MLRS, if our actor is to the left of the MLRS, it will give us negative values between 1 to 180. If our actor is to the right of the MLRS, it will give us a positive value between 0 to 180. I do not need this, I need it to be 360. So we use the clamp axis, and let's set the value. Previously we set it to between 135 and -135, and this leaves us with a 90 degrees arc that we do not need it to go, and this 90 degrees arc will be between 135 and 225. 135 and 225. If we are outside this angle, we do not need to shoot. We needed to change position. How we make it change position? Let's make another custom event. Call it change position. Let's say if the yaw let's take a range, and no, I mean range, range, in range. Let's see if it's between -135 and -180, which it means we are to the left of the and back onto the back of the vehicle, so we need to reverse and turn right to make it face us, or to make the launcher in our range. Now if it is between these, what we need the set input throttle to be reverse -1, and the steering input, I want it to turn right, so we'll make it to 1. and also need another check. Sorry, if it is between, this time the positive arc between 135 and 180, we take this and reverse them, or reverse only the steering. We also want to reverse and change location. Now after this we need now another check to make it apply brakes if it reaches the values we want. Like I said, I set it to minus 135 and 135. Now I will make it slightly lower because I do not want it to constantly change the position of the vehicle. Because if we set it to minus 135 and 135, it will be at the limit. When we move, it will continue moving. I will set it to 120 or 115, minus 115 to 115. If it reaches this, we want to apply brakes. Set brake input to what's the let's see the torque of the vehicle. 2000. Let's make it 3000. And don't forget here to set the brake to 0. Now let's change position. Now let's see. First, let me get rid of this one. I want a fast one, fast vehicle. I already made the BMP before. Now set the to BMP the actor. Now let's find out why. Let's see. Hello again. I read the logic for changing the position, and I will show you how I did what's the changes, because I had problems with the previous method. Previously it worked, but now it doesn't work. I think there is something wrong in Unreal Engine, but I changed it. Now we left before we check in the shooting event if the yaw value is between 90 and 270. Also, here we made a clamp. We need to move this clamp to the animation blueprint, because here it will cause some problems, because it will clamp the value, and when it's clamped it sometimes uh, give us problems in the when we want to find the player position. So move it to the animation blueprint here, view, better. Now let's get back to the Smerch blueprint. Now we need to calculate the rotation again. Let's copy this or duplicate by Control and D. Now, and this method is simpler than the previous method. The previous had a lot of booleans and it will affect performance. Now let's map range clamped. We need also the throttle, set throttle input and steering input and brake input. Now I will limit the value between minus 90 and 90. If we are outside this range, the vehicle will try to adjust its position. Now I had problems to make the vehicle reverse. I don't know why it doesn't reverse when I apply the minus 1 value. So I will keep it moving forward, and the steering, here we need the another value for the steering. Here the steering we will add minus 1 when we are to the left outside 90 degrees. It will go to the left, and if we are to the right it will go to the right. Now the brake input, I need when it is turning, I need the brake to be 0, and when it is when it should stop, when we are within the range between minus 90 and 90, when we are in front of the vehicle, I wanted to apply the brakes. So we need the absolute value. This will give us an absolute value that's always positive, and another map range clamped. If the value is 0, and if it is 1. If it is 0, I want the brakes to be applied, and if it is 1, which means we are turning and changing position, I want the brakes to be 0. Now let's Let's try it. Now it is changing position. Not sure. Now let me still changing position. It's keeping me inside the minus 90 and 90 degrees arc. If I'm outside the arc, it should not shoot, but I'm not going to get away. Now I will stop. Stop this. And I move. Now changing position. And it's faster. Turning the other way. Let me just change the angle of the launcher, because now it's weird. Where is the here? Let's make it 1000 to make it look like it is aiming at us. But if changing position, it does not shoot. Now let's make it more. I want the launcher looks like it is aiming at us. Away. Now let's recap, because let's make sure we made it right, and I didn't make some changes that you are not aware of. Now first, look at the player node, we checked for the range that we set as 100,000 units. Checked if the actor is the actor distance is below the range. Then we set the start point according to the socket. Then we set the angle of the launcher, which is only for visual effects, because the angle does not affect the projectile position, because it is predicted by our position and distance from the vehicle, and it is set in the velocity. And we set the yaw by finding the rotation of the actor, and then we set the endpoint as the actor position that we want to shoot at, and also this node is adjust velocity node, and the toss velocity. The speed we set at 10,000, and the shoot node we check if the actor is within this range between 90 and 270. If it is within this range, we change the position that we just made. Let me just comment on it. Position. I think the video is becoming too long. For the next videos, maybe we will make AI helicopter, or I don't know. I will think of something. Thank you for watching. Thank you very much.